Thank you. So this project's been 4 to 5 years in the making, so we're really excited to finally be able to share some preliminary results with you. This is shared work with Lars, who's in the audience, and Silvery and Flavio, who are back in Ithaca battling the cold. So before I get started, I just want to talk a little bit about the background of the state of replication in the economics profession. There has really been a long-standing history in economics, like in many fields, of understanding the importance of replication to the scientific endeavour. So way back in the 30s, in the very first edition of Econometrica, the editor made this comment that, as a rule, they'll look to publish the data alongside articles. Another top journal, the JPE, in 1976, actually established a confirmations and contradictions section, and this was promoted in large part by a paper they published in 75 that criticised the tendency of journals to focus an inordinate amount of attention on statistical significance and the consequences that has on the proliferation of type 1 errors. So that really kind of foreshadowed a lot of what we're talking about 40 years later. Unfortunately, although that section existed from 76 to 99, over that whole period, just 6 replications were published, and one of which was successful. One of the more kind of high-profile versions was in 1982 with an NSF-funded initiative set up at the JMCB, where they requested that when submitting papers, authors also submit code and data. There were mixed results coming out of that I'll explain in a sec. And then we get to 2005, where the American Economic Association kind of first established the policies that are shared by most top journals today, although it took a while for some to follow suit, so the QJE adopted something similar just a couple of years ago. Cool, and so I'm going to focus today on the AEA data policy, and this is it. Basically, it says that before publication, the authors submit all their data, all their programs, and all their documentation for how to run it. And if they cannot do so, then they need to talk to the editor in advance. And I'll get to, in our results later, that usually that's because if data is confidential or proprietary, then it's not supplied. So our project was to take the applied economics version of the American Economic Journal and replicate every single paper that was published since its inception, almost 10 years exactly. And so we're really speaking directly towards this policy. Okay, so given a little bit of context as to how open journals are to transparency, how does that translate into whether or not replications are done very much? The general gist is they're not often done. Okay, so I'm actually very aware that many of the people I'm citing today are in the room, so I just want to apologise if any of the numbers are slightly off. But yeah, so Moller-Langen and his co-authors searched all the top 50 economics journals over a period of 40 years. They got 126,000 and found that just 0.1% of them were replications. A similar exercise was done with a focus on development economics, and Duvendak et al. Actually searched all 333 economic journals on the Web of Science and found that just 16 of them had published more than 3 replications. It's important to note, though, that there is some pushback to this general idea that replication isn't popular. Most notably, Hammermesh kind of makes the case that, at least in some fields, the top papers tend to get replicated. And if we really care about the results that stick around, then those are the replications we should care about. And that if we focus just on formal kind of publications, then that misses a lot of stuff going on in the background. So whether that be papers being replicated as class exercises or implicitly within extensions to the papers. Okay, so given it's not common, what are the results when the replications actually do happen? In the language of Chang and Lee, who published a big replication exercise a couple of years ago, they're usually not successful. Okay, so these three, I don't want to spend too much time talking about them, but I mentioned earlier the JMCB 1982 initiative funded by the NSF. This pioneering article really by Daywald and his co-authors in '86 actually looked at papers published in that journal, requested the code, went through the process and found just 13% were able to be replicated. So these are all attempts to actually reproduce exactly what the authors did. A more recent paper did a slightly different exercise, more similar to what's going on in psychology, where they actually re-ran lab experiments and searched for results that remain statistically significant. Okay, so I've played kind of fast and loose a little bit with my terminology here. I think it's useful to kind of say what we mean when we're talking about replicability, reproducibility, etc. And we like to think of it on a continuum. So we have right over on the narrow side, reproducibility. So this is replicating the exact results of a published article using the same data code of the authors. And as we move towards a wider understanding of replication towards replicability, this is kind of understanding, whether a result can be established by collecting your own data. So the rehashing of lab experiments, for example, would fall under this heading. And then finally, we get even wider kind of sense of generalizability. So that is, okay, we've established the result, under which conditions does it hold? Does it hold in different countries with different demographics, etc.? And we're going to focus really on this bit. So in the tradition of today of citing Ted's work, he makes this statement in his gel paper published this year, and this is kind of, we agree with this, and this is what we're trying to get at in our exercise. Okay, so what did we do? Well, this was a summer research project where we dragged some unsuspecting undergraduate RAs from the lake into the lab, and we did this from 2014 to 2018. And we made sure that they kind of satisfied some minimum criteria, most important of which they were very familiar with how to code, mostly in Stata. I'll get to that in a sec. But this is an important point because I think implicit within any replication exercise is who is doing the replication. Here we're focusing on undergrads, so we're kind of setting a high bar in terms of what we're expecting from the authors submitting their code. And we ran a one-day workshop running them through the purpose of the project and getting them familiar with some of the technical aspects like version control systems and the Cornell cloud computing service which they used. Okay, and so what did we get them to do? Well, we tried to formalize this process as much as we could with the idea that we'd like other people to kind of replicate the protocol if possible. And so it was really a three-step process. So we took a DOE, took a journal article, assigned it to an RA, and got them to fill out an entry questionnaire that asked questions like, is the code available? What programming language it is it, was there documentation provided, etc., etc. And to ask them to give a subjective interpretation of the difficulty of replicating a particular article. Once they did that, we got them to actually download the code, put it in a repository, and fiddle with the code if necessary to try and reproduce the article. And then finally, once they were done with that, we got them to fill out a formal exit questionnaire as well, talking about, were they able to replicate the main results, what were the issues if they couldn't, etc., etc. And so we really gathered a lot of information about the replication process itself that I'm going to talk about. Okay, so let's talk a little bit about these articles. We gathered 303 of them. This isn't quite the full sample, so what I'm going to show you today is kind of subject to the 20 or so that are yet to be done. As you can see, we had a bit of a technical error in 2013, but we're fixing that at the moment. I mentioned that we had the RAs give a subjective assessment of the difficulty of what it would take to replicate these articles, and we had a pretty good spread across all of them. Okay, so Difficulty of 1 is all the data is provided, it's public, the documentation is really clear, the code's there, and we know how to run it. A difficulty of 3 was, the code is all there, but we don't know what order to run it. The documentation's a little ambiguous. And in terms of most difficult, stuff was missing that we couldn't even begin to attempt the exercise. What will not surprise the economists in the room is pretty much all the articles use data. There are pluses and minuses to this. First of all, it kind of somewhat assured us that our criteria that we used to select RAs, which was had they used data before, was successful, and they were. It is proprietary software, but it's relatively cheap as far as that goes. A lot of the packages, the extensions, are actually open source code. But having said that, there are some things about Stata that we could do with some improvement. One big example is that the SSC, which is the main repository for Stata programs, doesn't actually allow you to go back and get previous versions of packages. And for us, it didn't really cause that much of an issue because we're dealing in the last 10 years, but as you go further back in time, that might become more of an issue. We also asked a similar question with data, by the way. So we expected a lot of CSV files, but that wasn't the case. It was mostly the .dta Stata files as well. So in terms of documentation quality, it was pretty good. Okay, so only a few were missing some README files, or they were completely ambiguous as to not be very helpful. But most of them actually came with step-by-step instructions of how to run the code, so it was good. And now turning to our results, these are our main results. So we've the biggest reason, or the biggest barrier to unsuccessful replication was missing data, and in particular data that was missing because it was either confidential or proprietary. So we split this out a little bit. The top bar was confidential data that was picked up at the entry questionnaire stage so that we didn't even attempt to do it. The bottom pinkish part of that bar was confidential data that wasn't obvious at the assessment stage, and it wasn't until we actually got replicating that we realized, okay, we're missing some data sets here. Okay, so total success rate, about 25%, but if we're kind of conditioning on the fact that the data was available, it shoots up to about 43%, and so that's total success, replicating the numbers exactly within all the tables in the document. There was also a substantial number that were partially completed, so over half of the tables numbers were exactly replicated. Okay, and these are just some reasons other than confidential data for why some replications were unsuccessful. The main thing I want you to take away here is it's pretty sparse, so confidential data is really the main thing in the way here. There are a few things such that the data was provided but couldn't be loaded by the code, etc., but these really weren't that big a deal. Of those that we were successfully able to replicate, we asked the replicators to describe what changes they needed to make to the downloaded code. And a third of them actually required complex changes. So this isn't just downloading and running, or downloading, changing directory references. This actually involved digging into the code itself, understanding it a little bit, and changing it around to get a good result. So that leaves something to be desired as well. Right, so we actually, there's kind of an understanding in the literature, I guess, that documentation is really important. It's not enough to just submit your code, but you need to tell people how to run it. And our results really kind of support that. So when there was good documentation quality, it was associated with higher success rate in replication. We also downloaded a bunch of citation and author statistics for these articles, which allowed us to kind of look at relationships to do with replication and the subsequent performance of these papers in terms of citations. One thing we found is that there is a kind of a citation bonus for using confidential data. So those papers that use confidential data were more likely to be cited. And then finally, we wanted to understand whether or not there was a relationship between the ability to reproduce a paper and the subsequent citations, controlling for author reputation as proxied very imperfectly by their H-index. We essentially found that there was no real relationship. So authors with higher reputation tend to get cited more, and it probably doesn't come as much of a surprise, but conditional on that, the fact that their article can be reproduced doesn't really have an effect on future citations. Okay, and just to recap, nothing new here. We're kind of speaking directly towards the AEA's data sharing and transparency policy. And even in an article that has this, and for which most articles are empirical and provide their code, there's just an overall 25% success rate and 43% conditional on actually providing non-confidential data. Thanks.
So great to hear this. So I would like to get a bit more of a sense of the cases where they didn't replicate. So let's say I've had cases where I submitted an article for publication, and in the proofreading stage, I noticed there were mistakes from going to Excel, and basically you wouldn't have replicated if I hadn't picked it, and it was totally a proofreading error, but maybe they changed a number of digits, whatever. What share of the non-replications actually would have changed the message of at least one specification? So is it like one digit didn't match, but that was a rounding or whatever? I mean, there is a difference between some human error somewhere in the stage from early to very final versus we change the message of this paper. And I think we really care about that distinction.
Yeah, that's a good question. And we kind of, basically our policy was, if the number was exactly matched, then that was successful. And if not, then they came to us as their supervisors and we made a decision as to whether or not that was significantly different. That's kind of, we think that that approach is justified in the case we're directly reproducing numbers. Now, of course, if we're rerunning lab experiments, then we wouldn't expect estimates to be exactly the same, and then we'd shift a focus to whether statistical significance is maintained, for example. But your question, I kind of skipped over a little bit the fact that we termed a lot of these as partial reproduction, and your kind of case would really slip into those, and we need to kind of dig into that a little bit more. So partial reproductions, again, were some numbers in some tables are accurately reproduced and others were not.
And that's the important point, is that the partials actually get at what you're saying, essentially, that a good chunk of the paper was reproducible, then was a partial one, which was another 43%. So that brings it up to about 80 that has some portion of the papers that are reproducible. The rest are mostly not reproducible, which was another category which we just lumped into the does not reproduce part. And we asked for what the code changes were necessary to do this, so they actually attempted various code changes, and the number of complex changes that they identified increases with partial to non-reproducible as well, but caveated here, by the perception by an undergraduate student who doesn't necessarily understand the entire paper. He's told, replicate this, compare the tables, etc. Many of the partial or non-reproducible ones were that literally there was no code for the table that was there. Or there was 800 pages of code output and nothing identified what was table 8. So those things are possible. They guide where we might head with this, but it ultimately is, this is a perception of an undergrad tasked with a simple task of read the README, run through the code, and figure out if you can find all the tables in there, right? So mostly or not at all reproducible is just what we said. Partial and captures at least half of what's going on there. So not bad, but not perfect either.
So one question about, I'm curious, how did you code cases where there was some highly confidential data like tax information that it's later on aggregated at a high geographic level, and that's the data that is posted with the code. How would that be?
Yeah. So we kind of glossed over the ultimate provenance of how the data provided to the journal came about. So in that case, where sure the ultimate source was confidential, but the actual data supplied was some kind of publicly available aggregation, we would call that a non-confidential reproduction.
My understanding from the far left of the replicability spectrum where you were looking is that being able to reproduce the paper is very helpful for me to go through and potentially find errors in the coding. And so many of the errors that I've seen in economics papers and working papers happen at the very beginning stages in the data cleaning and data preparation areas. It's typically a research assistant who's doing the work, and maybe they're unfamiliar with and errors can creep up there. In the AER data that I've seen in the past, much of it is already cleaned. And so I'm wondering how, in this exercise, did you actually capture that piece of this at all? No.
Yeah. No. The answer is basically no, but
we do have some measure of what number of data, and we haven't analyzed that for this paper. We asked them to sort of think of simple raw data analysis data tables. Right. And that's a simplification that doesn't capture a lot of the complexity in most of the papers. And asking an undergraduate to get that right, who haven't been through the training that graduate students are supposed to have gone through to get that right, who don't then get it right, is a bit too much to ask. So we have a very noisy estimate of that. In general, the data policy doesn't ask for that. They ask for what is the analysis data set, and how you got there, you can keep that wherever you want to go. Whether we want to make that more transparent in the future was part of the effort of digging into this. We actually wanted to know, empirically, how often is it obvious what is the step from raw to analysis data to the rest of the stuff. The data policy only asks for the latter part. It does not ask for the first step. So yeah, well, we might have some analyses on this in terms of were our undergraduates able to discern this in complex environments? My memory from looking at it is that most papers don't even make that distinction. And that simply is not something that one can empirically look at because it just doesn't happen very often.
I share your concern though that these researcher degrees of freedom often come in a lot earlier in the production pipeline. But yeah, we just don't observe that. Yeah.
Time for one more question.
You had a slide where you were showing whether nothing had to be done to the code versus there was more complex change that needed. And I was wondering, within that complex change bar, how much of that is due to like a new computing environment? So how much of it is packages were broken or updated since then versus they actually had to manipulate code in a different way? Do you see what I'm saying?
So in a future version of this, we're going to speak to that in more detail. And the reason we can do that is we got them to make all the changes in a version control repository. So we can actually kind of look at the code and count the number, at least, of line changes from their initial commit to the repository to the final. But yeah, that's a good question, something we're looking at.